All right, good evening, everybody. Welcome to ANT 324, introducing Amazon Kinesis data streams on-demand mode. My name is Sai Madali. I'm a principal product manager with the Kinesis data stream service. Yesterday morning in the keynote, we announced in general availability the new capacity mode for Kinesis data streams. Just a show of hands, how many of you are aware of Kinesis? How many of you actually use Kinesis today? It's a pretty good population, I guess. So what we're going to do today is we're going to obviously dive into the feature, the capability. Before we do that, though, I want to spend a little bit of time on what is streaming data, why customers use it, a quick intro on Kinesis data streams just to kind of level set everybody at the same pace, and then we'll dive into the feature. Okay, so let's get started. Now, the first thing I want to start off with, one thing that most of us would agree is that the adoption of streaming data has kind of increased over the last several years, right? So there's an explosion of use cases. And I believe the reason that it is really driven by our collective motivation to serve our customers much faster. We want to address their needs very quickly as they come by. Now, this need exists across many industries, right? Whether it's about you're a gaming developer, operating a gaming platform, you want to collect clickstream data, how users are interacting with the game, get a positive feedback loop, enrich their overall experience, tailor the game for their experience in real time, and obviously that drives a lot of loyalty and adoption from your customers. Or it could be a financial customer who wants to track millions of transactions globally to identify fraudulent transactions, anomalies, so that you can actually send real-time notifications to users every time you see an anomaly. Or you could be building an observability platform, right, where you're collecting logs from applications, from servers, from sensors, and basically looking at patterns, right? You're trying to detect if there's an issue before it actually shows up. A customer calls you. If you know what the issue is, you can proactively address that. Again, it helps enhance the customer experience in that use case. Or it could be an IoT use case, right? So you could be collecting sensor data on the shop floor, on the factory floor, and processing that in real time to do things like predictive maintenance of your machines, right? Just to know, based on historical trends, based on what's happening, do we need to perform a maintenance task for it? And that is important for you to keep the uptime of that machine and make sure, defects, if you will, are reduced. This need exists across many domains, right? Hopefully some of these use cases resonate with you. You're probably already operating some of these use cases, or you're looking forward to do it. Now, what customers told us is, while these use cases offer a lot of potential, building a streaming data platform can be tricky, right? You have to, figure out what instances, what storage, volumes you have to pick. You have to kind of cobble all these parts together. And customers said, hey, we don't want to do that heavy lifting, right? We just want to focus on building these applications, serve our end customers. And that's really where Kinesis Data Streams comes in, right? It's a serverless streaming data service offered by AWS, where you are basically interacting with the higher level abstraction layer of a stream. So you're not worried about instances or storage volumes. You're really focused on creating a resource, telling us how much capacity you need, and reading and writing data, or writing and reading data from that stream. At a core level, what Kinesis does is it allows you to ingest high volumes of data from a wide variety of input sources. Could be sensors, applications, servers, and so on and so forth. And then what you do is it stores the data and makes it available for low latency processing using either other managed services like Kinesis Data Analytics or Lambda or EMR, or you could be building your own applications on EC2 or ECS. So this really gives you a lot of flexibility in how you want to consume the data and what you want to process with that data. All the data written into Kinesis data streams is stored durably across 3 different availability zones. It also provides you a 99.9% SLA on availability. That gives you the confidence to deploy mission-critical applications on Kinesis data streams. Kinesis data streams also enables you to do multiple things with the same data, right? So say I'm building an application. One application could be, I am trying to show the top 10 most popular products by my customers. That could be one use case. Another use case could be sending the same data to a financial system so that I can do things like accounting, right? Another use case could be sending the same data to a marketing data warehouse so that an analyst can drive insights of the data. So what Kinesis allows you to do, Kinesis data streams, is that you can add different types of consumers using a feature called enhanced fan-out that allows you to do different things with the same data. One of the other benefits of using Kinesis data streams, you can get to really low latency processing. So if you have use cases where you want to have an average latency of 70 milliseconds, you could use enhanced fan-out to deliver that capability for your use case. So let's talk a little bit about how Kinesis works today, right? Before we jump into on-demand capacity mode. Like I said, the core resource of a Kinesis data streams is this data stream. And the way you interact with KDS is you create the stream. Today, you provision these units of capacity called shards, and then you basically write and read the data from it. Now, shards in Kinesis data streams act as a unit of throughput. Each shard provides 1 megabytes per second and 1,000 records per second for writes, and 2 megabytes per second for reads. So depending on use case, and depending on your throughput requirements, you would specify the number of shards. So say my use case requires 2 megabytes per second, I would start with 2 shards. And obviously, application needs change, right? So you might need 2 shards today. Tomorrow, as you add more users, as you launch in more geographies, you obviously want to add more capacity to your stream. So what you can do today is you can add more shards, right? So you can keep adding shards to increase the capacity of your stream. Shards in Kinesis also act as a unit of parallelism, right? So if you remember the core use case, how do I ingest these large volumes of data, in some cases gigabytes per second of data, and I need to process that at really low latency. The way I do that, and how shards enables us to do that, is it allows you to partition your data into small chunks that you can process, each at most 1 megabytes per second. And that gives you predictable performance for your consuming applications. It knows that at most, I would be processing 2 megabytes per second, right? So that predictability is what allows you to always make sure your insights, your processing is the latest and greatest, and the insights for your customers are really not delayed. That's how Kinesis data streams works today, where you are responsible for creating a stream, telling us how much capacity you needed, and then manually scaling that capacity as and when you need it. This approach works great. Customers said this approach works great for a majority of use cases. Where I know what my traffic patterns are, and I know how many shards I need, and when the baseline increases, I would just go add more shards. It works great. I don't have to deal with any servers or storage. This works great. Now, the reason that is the case is, let's take an example to understand what I mean by that, right? What is a stable workload? As you can see in this example, the blue line is the actual data ingest, which ranges between 40 gigabytes per hour to a peak of 60 gigabytes per hour, right? And somewhere in the evening, when people come back from work, let's just say this is an example of a video streaming platform, on demand, people log in, they come home, watch the video, so you see a spike. But the average was somewhere around 40, right? So 40, 45. And the ratio between your peak and average is pretty low. 60 by 45 is close to 1.2 or so, right? It's pretty low. Now, in this case, what do, right? You provision for the peak, right? So you provision for the 60 gigabytes per hour. So what this means is your utilization is significantly high. Or, put it another way, the amount of unused capacity, right? Because you're provisioning for the peak, so the amount of capacity that you're not utilizing during the non-peak hour is significantly low. The shaded thing in orange, as you can see here, that unused capacity is typically low because the peak to average is pretty low. It's also easy to plan, right? Because I know what my peak is usually. It happens in the evening. I'll provision it for the peak. And I'm getting a fair amount of utilization out of my resources. So it's pretty easy to work with provisioning and scaling capacity. However, though, as streaming data becomes more ubiquitous, right? You're using that for many more use cases. There are more workloads today where the capacity or the demand can increase significantly within a few minutes. Like it can happen very quickly, right? So a good example of that is what we call a highly variable workload. Again, a similar use case. Again, the same provider, a video platform provider. Now, this data stream processes records for a live broadcast thing, right? Like live video streaming. Now, what happens in this use case is in the morning time, not a lot of traffic, people come home, and they're catching up a lot on the live TV, right? So now your peak here is 80 gigabytes per hour. The average is somewhere around 20. So the challenge here is the ratio between the peak and average is pretty high. It's about 4 compared to 1.2 in the prior example. So what you're doing right here in this example is you're still provisioning for the peak, which is 80 gigabytes. And then what happens is during the non-peak time, the wastage of resources is pretty high, right? So all that shaded orange area that you see there is what you're paying for, but you're actually not using for. So one quick clarifying thing is in Kinesis data streams, in the current mode, in the mode where you're provisioning resources, you're paying for that fixed capacity, right? So because you're paying for that fixed capacity, and you're not utilizing that during the non-peak hours, you are in a way, not getting most of what you're paying for. Now you can say, yeah, I can manually scale it, and customers do that today, right? So they monitor traffic, they scale it, but sometimes, that can be very tricky, right? And a good example of that is the same customer. Now in this use case, they provision it for 80 because that is their expected peak, but it's a live video streaming platform. On days there are live news events, breaking news happens, right? And then suddenly you see a significant increase in demand, like 2x more than your prior planned capacity. So you're looking at 160 gigabytes per hour compared to 80 gigabytes baseline that you've always interacted with. This is a double whammy, right? Because what happens is I'm not only not utilizing what I'm paying for during the non-peak hour, I'm also not having enough resources when I need them, and which is actually impacting my performance, which is the shaded area in red. So to kind of summarize, right, what customers said is, hey, the current way to work with Kinesis data streams, which is provisioning, scaling resources, works great for the stable workloads. But then you have these unpredictable workloads. You've got these highly variable workloads where capacity planning can be really tricky, and we really want to optimize this problem, right? We want to reduce not paying for idle resources, the orange part, and we don't want to be in that problem where you see the red shaded area where I'm having performance challenges. What customers say is that when I have 3 workloads, maybe this is solvable, right? I vastly over provision, maybe I'm okay. But what if I have dozens and dozens of workloads, right? And across different business units, you go through this capacity planning exercise, and identify your requirements. I sit down with your business, identify where their launches are going to happen, when they're going to happen. There is a certain amount of uncertainty as well, right? So say if I'm launching a new product, I don't know how successful it's going to be, right? It might take off, and I can see a significant increase in demand, or it may not take off, right? So it's planning around for these scenarios could be very tricky. And again, like I said, when you're building streaming data workloads, some customers, kept and asked us, and, we don't want to be spending time on worrying about capacity planning and just gluing different pieces together. What we really want to be focused on is just building applications, and we want you, or rather we want to offload that capacity management over to AWS, and we manage that on our behalf, right? So that was one of the fundamental questions that customers asked. Can you make capacity planning for streaming data a lot more easier? Can we get that easy button? To address this problem, we built and announced yesterday in general availability Kinesis Data Streams on-demand capacity mode. It's a new feature of KDS where you don't have to worry about capacity planning. Streams automatically scale as and when there is an increase in traffic. So let's dive into this. When we built this feature, or rather when we started building this feature, there were 4 key things that we kept in mind. The first one, it has to be truly hands-free capacity management. Right now, we don't want you to worry about, hey, what knobs do I use? Do I have to scale fast? Do I have to scale slow? If I do scale up fast and scale down faster, will I have problems, right? So there's a lot of this planning that you still have to do, even if we automate and give you the controls. So it has to be really hands-free capacity management. It also has to be seamless, right? It has to learn based on your traffic patterns because they change all the time. So what works today may not work 6 months from now or a year from now. So it has to be adaptable. And it also has to be seamless, right? So that every time I'm scaling, I don't want to disrupt my production of data into Kinesis data streams or reading from Kinesis data streams. That has to be non-disruptible, right? So it has to be seamless. The third important pillar is that you want to, you use Kinesis data streams for a set of reasons, right? Low latency, high availability, the 3 A's durability that we talked about, high performance. You don't want to sacrifice those requirements just because you want to have hands-free capacity management. So we had to retain some of those core capabilities of KDS. The last one goes back to a problem, right? Why do I pay for unused resources, right? That orange shaded area that I talked about. I don't want to pay for non-peak hour capacity, right? I want to pay for really what I use. That was the fourth key pillar, the key benefit that we included, if you will, in this capability. So we've talked about some of the use cases. We've talked about why customers asked for this feature. Talked a little bit about some of the core principles that go with Kinesis data streams on demand. What I really want to do next is talk about a little bit about how it works, right? So that's really where the core of this discussion would be. So you can get started, and obviously, just like today, you create a stream. Now, instead of telling us how much capacity you need, you don't do that anymore. You select between the on-demand mode, which is the new mode, where capacity is managed for you, or you can continue to use the current mode, which is the provision mode, right? So you can still say, I have a stable workload. I think I'm good with what I have. You can absolutely continue to use the provision mode. We're going to call it the provision mode going forward, by the way, where you're provisioning shards and scaling up capacity. Or you can choose the on-demand capacity mode, right? So getting started on streaming data, right? This is the first workload that you're adopting, or it's a relatively new workload, unknown workload. You create a stream, give it a name, and you're done. You can continue to use the same APIs to write into a data stream in the on-demand mode. So put record API, the put records API, those continue to work as is, unchanged with the on-demand capacity mode. You still will be using a partition key to write data into Kinesis data streams, right? So you still have to partition your data, right? Because you want to make sure you can ingest large volumes and process that at really low latency. So the need key to write into Kinesis data streams continue to exist. You can also use the same get records API, subscribe to shard API. So Kinesis data streams provides you two APIs, the get records API, and then the subscribe to shard API for low latency reads. We talked a little bit about this with the enhanced fan-out feature earlier in the presentation. You can use both those APIs to read data. What this also means that if you have a pipeline today, right, where you are ingesting data from, say, CloudWatch logs, right, into a Kinesis data stream, and then using Lambda to process that data, you can continue to use those integrations as is. They work as is because the APIs don't change. You can continue to use those integrations without any changes. One of the other key things is the shard definition, which is 1 megabytes per second and 1,000 records per second for writes and 2 megabytes per second for reads, does not change. Like I said before, that really gives you predictable performance for your consuming applications. So that core construct of KDS does not change in the on-demand capacity mode. All right, so that's how I get started, right? Creating is very easy. There's also a second way to get started, which is I can take an existing Kinesis data stream, right? So that's already, you are managing the capacity, provisioning shards, scaling shards in a way. You can move that to on-demand mode. And that switch is absolutely seamless, right? It goes back to the pillar that we talked about. There is no disruption to your write applications or read applications when you switch it from the provision mode to the on-demand capacity mode. Now you can ask me, hey, Sai, can you move this from, I moved it to on-demand mode. Can I switch it back to provision? Oh, absolutely. Now, why is this important, right? So say, I go back to the example, right? I am launching a new product. I don't know what the demand is going to be, right? So I can get started with the on-demand capacity mode. Over time, I understand what my requirements are, right? And then I can choose to come back to the provision mode just as my needs change, right? So it gives you the flexibility of operating across both on-demand and the provision modes. Let's talk a little bit about what it means when you switch a stream. When you take a provision stream and you switch to on-demand, we retain that shard count as is to start with. So if you have a 40 shard stream, it'll be a 40-shard stream in on-demand. And then we're going to touch about the scaling policy, how it will evolve over a period of time, but the starting point is what the number of shards you have. Now, when you switch a stream from on-demand to provision, you still will have the same number of shards, right? And then you can use the scaling APIs, the split API, the merge API, to basically reduce the capacity of your stream, just like you do today. So that's what switching off an existing data stream into on-demand looks like. You can either use the console, like I show here, or you can use the new update stream mode API or CloudFormation to basically switch your existing streams into on-demand. So let's talk about the scaling mechanism, right? So the two key things that I want to talk about is this is the new stream creation experience, and then there is the provision stream experience, right, when you switch from provision to on-demand. So when I create a new on-demand stream, by default, I get 4 megabytes per second and 4,000 records per second for writes, and 8 megabytes per second for reads, right? Again, similar to a shard model where you have 1 in and 2 out, you have the same approach here with 4 in and 8 out. And as your traffic evolves, which we're going to talk about, the stream scales up to 200 megabytes per second and 200 records per second, or 400 megabytes per second. So as your traffic changes, as your needs change, we keep scaling, and that's the maximum limit, if you will, for an on-demand stream today, to which we would scale the capacity. So the scaling mechanism, which is the heart of how on-demand works, is really predicated on two key things. The first is we want to make sure we have enough headroom for you to be able to burst to a totally unknown amount of demand that you are seeing, which is that 2x your last peak, right? So say your last peak was 20 megabytes per second, you can scale up to 40 megabytes per second. Now this also evolves, right? So say you're seeing this increase in demand. So your demand grows from 20 to 25 megabytes per second. Now we'll scale again to 50 megabytes per second. So we keep doubling this capacity until either you hit 200 megabytes per second or you basically have at least 2x your last peak. So which means that you can actually burst very quickly without ever being throttled. Now, what happens if I have demand that exceeds my 2x my last peak, right? And what happens in that case is we continue to scale, and that scaling can take up to 15 minutes. It can be faster, but it can take up to 15 minutes. It may take 15 minutes in some cases. Each on-demand stream also provides read throughput that at least is 2x the write throughput, right? So again, goes back to the shard definition, 1 in, 2 out. You always have at least 2x the write throughput, and in some cases you could have more. But what happens, what do I do if I want to add more consuming applications? Well, then I can use the enhanced fan-out feature, which allows me to add more than one application or more than 2 applications to an on-demand stream. And I can keep adding up to 20 consumers to an on-demand Kinesis data stream. So that's how the scaling works. So now I come to my favorite part of the presentation, where I want to talk a little bit about how all of this kind of comes together, right? So just a quick recap, right? So we've talked about what does the initial experience looks like, which is 4 megabytes per second. We talked about the fact that you can seamlessly switch from provision to on-demand. And when you do that, you retain the same shard capacity. And we've talked about the scaling experience, which is you always get 2x your last 30-day peak. Now let's see how all of that comes together. So in this example that I simulated, you're basically, I create a provision stream, which is how I do today, right? Like I create a stream, I've given 5 shards to it. And for the first 3 minutes, I ingested 4 megabytes per second, right? So no throttling. As you can see, the red line, which is the put records percentage throttle. So the percentage of records that are actually throttled. And the green line is the amount of data that has been ingested into the stream, right? So the ideal scenario is the red line should be almost 0, and the green line should be what your data traffic should be, right? That's the ideal use case. So what happens is at 2119, I basically increase the throughput to 12 megabytes per second, right? Because I just got more data. I saw a spike. Now the stream obviously can't handle that because I have 5 shards and I'm getting 12 megabytes per second. Each shard gives me 1 megabytes per second, so the throttles increase essentially almost up to 60%. Now what I do is I take the stream, right, at 21 23, I take the stream, and I will switch that to on-demand mode. Notice that the moment you do that, it immediately starts scaling. So I start with 5 shards. I can see that the traffic is 12 megabytes per second, so I have to scale. So I immediately double the capacity to 10 megabytes per second. And as you can see here, within 3 minutes, by 21:26, the throttling has significantly reduced from 60% of records to 20% of records. But I'm just not done yet. The other thing that you want to see here is that there is no disruption to your throughput, right? As you're moving from provision to on-demand, ingestion is happening, consumption is happening, no disruption whatsoever. And as I now have to scale further, what I do is, the on-demand stream understands that, hey, I have to keep scaling. So it again doubles its capacity to 20 shards. And as you can see here, by 21:30, the throttles have completely reduced, right? What happens now is, okay, this is great, everything is working great. Now what if I increase my capacity to 18 megabytes per second, right? So because I just have more throughput that is coming in. Again, Kinesis says, okay, yeah, this is not 2x, right? Because I only have 20 shards, so it again scales to 40 shards. Because it wants to make sure that you can at least get 2x your last peak, which in this case is now 18. So it scales up to 40 shards, and within another 5 minutes. So what you see now is you have 40 shards in your on-demand stream, so you can actually scale your overall throughput to up to 40 megabytes per second, and not worry about having any throttles, if you will. So, yeah.
So when the initial throttling happens, will it set off any CloudWatch alarms that we have configured?
So you would continue to receive write throughput provisioned exceptions. Sorry, just to repeat the question was, are there any CloudWatch alarms that you would get when you see throttling? So just to talk a little bit about throttling, right? So just today, when you write to a Kinesis data stream, and it exceeds the provision throughput that you have, you basically receive write throughput provision exceeded exceptions, right? And you have to retry those requests, and SDK, the AWS SDK has its own exponential back-off mechanisms to kind of give you that additional resiliency. But what you see here is you continue to receive the same throttles, right? But we would actually, given that we know that the fact that, hey, your load is increasing, we would keep doubling the capacity. So there aren't any new CloudWatch metrics that tell you that, hey, you have to take an action, because ultimately, that's the point, right? You don't want you to focus on worrying about taking an action. It's us understanding that, hey, this is a consistent increase in traffic, and we have to continue scaling until the throttles are fully reduced, essentially.
Can it scale down?
Great question, right? So like I said, one thing that we talked about is, if you look at the principles, is it should be hands-free, right? Now, why do you want to scale down? Let's ask that question. Why do you want to scale down? The reason is I don't want to pay for that capacity, right? Now, the beauty about on-demand mode is you predominantly pay for data in and data out. So you're paying for your 18 megabytes per second, 14 megabytes per second of throughput, and you're not paying for 40 shards, right? So you as an operator, or rather, you as a user of an on-demand stream, you're not worried about scaling down, because you're not paying for that fixed capacity that we maintain for you to burst up to 40 megabytes per second. You pay for your throughput, whether it's write throughput or read throughput. So that takes away this whole complexity of, hey, do I have to scale down capacity? All right, so that actually brings me to the pricing, right? There's never a discussion that's done without talking about pricing, right? So my favorite part of the presentation. So there are a few dimensions that I would want to talk about, obviously. The first is when you create a stream, right, in on-demand mode, there's a per hour charge of 4 cents, regardless of your usage, essentially. Beyond that, though, you pay for the amount of data that is written into the stream and data that is read from the stream. Now, if you're using an additional feature like enhanced fan-out, there is an incremental cost, which is 5 cents compared to 4 cents per gigabyte with the Get Records API. And then say you decide, 24 hours retention is what I need, right? Because as you know, Kinesis data streams by default supports 24 hours of data retention, which can be extended up to 365 days. So you could say, I'm good with 24 hours of retention. Now, why do I need retention, right? The reason I need retention is I want to build durable applications. I want to replay some of the data so that if there is a downstream failure, I need at least some headroom to replay all the data. So that 24 hours of retention gives you that additional headroom. The cost of retaining data for 24 hours is bundled, if you will, or is part of the data in pricing. So there's no separate pricing for you to retain data up to 24 hours. However, if you decide to retain it longer, say up to 7 days, and now you do that because you want to give yourself more headroom, right? You basically pay EBS-like pricing, which is 10 cents gigabyte a month. You pay per the hour, you pay for the amount of data that you're storing, so it's really usage-based pricing as far as the storage of data is concerned. Now, if you say that, hey, this is great, 7 days is great, but I have a compliance requirement where I have to retain my data even longer. I have to retain it for up to 365 days, right? So then I can use what is a feature called long-term retention, and that allows me that basically bumps down the rate to 2.3 cents a gigabyte a month. So as you can see here, predominant way we charge customers in the on-demand mode is by the amount of data in, data out, and data stored, and it kind of depends on the feature that you're opting in. So to your question previously, you're not really worried about scaling down capacity because unlike in the provision mode where you're paying for the shard hour predominantly, here you're paying for the throughput. So the other important point that I want to talk about pricing in general is with Kinesis data streams in the on-demand mode, we're basically using a 1 kilobyte rounding factor when you write records into Kinesis data streams. Now, why is this important, right? Today, if you're using Kinesis data streams in the provision mode, we have a rounding factor of 25 kilobytes, right? So if you're sending a record that is 4 kilobytes in size, we round it to 25 kilobyte, and that's how we meter, if you will, on one of the dimensions in the provision mode. That means that you have to aggregate. Now customers want to aggregate more records, right? So say you have 3 records that are each 4 kilobytes. You might want to combine all of them together and write it as a single 12 kilobyte record, and which is what's called an aggregation in the Kinesis data streams world. You don't have to worry about in the on-demand mode, right? Because your typical record sizes are anywhere between 1 and 4 KB. The rounding factor works great, so the applications that you're building can be vastly more simple in the on-demand capacity mode. Again, one of the themes that you would see here is that the idea with the on-demand capacity mode is to make it easier for you to build applications where you're not worried about managing capacity, optimizing things around. You're basically focused on building applications. Another important question comes is, okay, how do I think about when to use on-demand versus provision mode? So the first answer is it really depends, right? It depends on how well you're utilizing your resources, what record sizes you have, depends on how many consumers you have that are reading data from that stream. There are multiple factors that goes in when you are comparing on-demand versus provision mode. But the rule of thumb that we typically see is that if you're having streams that have less than 10% utilization, so what I mean by that is you go look at CloudWatch metrics, you know how many shards you have on a stream, and you can look at the average throughput, right? So if I have 100 shards, if my average throughput is 10 megabytes per second, my utilization is 10%. For some of those use cases, it's actually cheaper to be using on-demand mode because you're not paying for the underused capacity, you're paying for the throughput primarily. So it's actually cheaper to use on-demand mode versus the provision mode. So let's talk about, how do I choose between provision and the on-demand mode, right? Because again, like I said before, you can continue to use that approach of creating shards, or rather provisioning shards, scaling up capacity up and down as you need, or you can let AWS do that using the on-demand mode. So you have 2 things to choose from. Let's walk you through some examples on how we think it might be helpful to compare on-demand and the provision mode. Say you have a stream that has really unknown traffic, right? Back to that example, I'm launching a new thing. I don't know what my throughput requirements are. Where do I get started? I don't know, right? So in that scenario, using on-demand might be the best option, because we would adapt the stream capacity as your workload needs are changing, and you're not paying for that underused capacity during non-peak hours. So that's ideal for the on-demand use case. Now, what if I have a predictable traffic pattern? I know exactly when my peak is, I know it doesn't go beyond a particular point, and I can drive up to 30, 40% of utilization typically on that data stream. And obviously, in that use cases, using the provision mode works great. Right? Again, you have the same capabilities, the same features across both modes, so you can continue to use the provision mode for those use cases. We talked about this. If you have unpredictable traffic patterns, right? So where your peak is 6x, 7x your average, right? Or 10x your average, or even more than that, then it's also unpredictable. You don't know when it's going to happen. You don't know, you can't really predict it. You can't plan around it. For those use cases, on-demand works great, right? Because it will adapt. And like always, you pay for what you're using, not for short hours. So that makes it much more economical and useful to use the on-demand mode. Similarly, if you have a consistent pattern, so you have a cyclical pattern, every day, 1 p.m., it goes up, it goes down at 5 p.m., goes back up again in the morning. So you have a very cyclical kind of a workload. For those use cases, you could actually use the provision mode, use the scaling APIs to scale up at a predefined point, scale down when you don't need that capacity, scale back up again. And so you can keep using the provision mode and the scaling APIs, the split API, the merge API, the update shard count API, to be able to use, rather optimize your costs, as well as balance the high performance and availability that you're looking for. Provision mode works great for those use cases. We've also heard from customers that, hey, when I have dozens of workloads, right, when I have a lot of streams, and I just don't want to manage capacity for these streams. When I'm managing 10 streams, maybe it's easier, but when I have 200 streams, I have 300 streams, it's pretty tough for me to think about capacity management across all these streams. For those use cases where I prefer the ease of use, on-demand offers you also lowest cost of ownership, right? Because you're not worried about, hey, I set up monitoring, alerts around it, have to have somebody, kind of monitor things, make sure things happen consistently. I don't have to worry about that, right? So there's a low total cost of ownership angle associated with the on-demand capacity mode. However, say you want predictable costs, right? So you want to know that, hey, I always want to have 100 shards. I know exactly what I'm going to pay for. That works great for my use case, right? So that's, at that point, it's great to choose the provision mode, right? Because you know exactly what you're paying. The other reason you might want to use the provision mode is when you have specific workload patterns. One example is, we've talked a little bit about this, is when you write into a Kinesis data stream, you could use a partition key, which KDS uses a partition key to assign records to different shards. That's how it works. However, if you have a use case where you want to use an explicit hash key, right, where you want to say, I want to write to shard 1, right? That's my use case because I want records always to be assigned to the same shard, and thereby I can process those records together. That's my use case. For those use cases, the provision mode gives you the control because you can tell I have 10 shards, right? And I can say I will write to shard 1. I'll always write to shard 1. But if you run it on demand, we will split that shard. We could merge shards depending on our promise of scaling, right? So it might not lend well in the on-demand capacity mode scenario. The other use case where provision continues to give you better economics is when you have test dev workloads, right? So, you can create a one-shot stream, that costs you 1 cents an hour, right? So that is ideal for test dev workloads. The last use case where provision works great is when you actually use shards as a unit of parallelism, right? So each shard provides 2 megabytes per second. But say you have a slow consumer that can only process 200 kilobytes per second, right? It can go beyond that, right? So what you do typically is you just have more shards because you need that predictability of 200 kilobytes per second at any given point of time, right? So you over-provision your stream, you have more shards just because you want to have more parallelism. Again, because you don't control resharding in the on-demand capacity mode, the provision mode can work or may continue to work great for those use cases. The last difference between on-demand and provision mode is generally the limits, right? So in the on-demand mode, like we've talked about, you're looking at 200 megabytes per second of write and 400 megabytes per second of read throughput. So you start with 4, and you can grow all the way up to 200 megabytes per second of write, but that's the limit at this point. However, compared to that in the provision mode, you have no limits. You could have as many shards in a stream, and you can scale up to gigabytes and gigabytes per second of data as you write into that Kinesis data streams in the provision mode. So this is a snapshot of how one would consider choosing between the on-demand capacity mode and the provision mode. So that kind of is what I had in mind when I want to chat about the KDS on-demand mode. It is available in general availability, rather, in all AWS commercial and China regions, so you can get started today. We've got a blog post that goes into more detail. Documentation is updated. APIs as well are out there. You can get started today. You can take an existing stream, move it into on-demand. Love to hear your feedback as you try on-demand mode. With that said, I now want to open up for questions. Yes, please.
What do you do for performance test environments?
For test environments?
Performance tests. Would you
Oh.
mirror production or always have it on demand?
Yeah, that's a great question. So you could absolutely use on-demand for that, right? So where, say you want to test, I don't know, 100 megabytes per second, right? Because you want to test your stream, what happens. So you can certainly use the on-demand mode for those use cases. And once you're done with your testing, you obviously can, delete that stream or retire that stream. So again, it works great for those use cases, absolutely. So, please.
Is the 30 days configurable?
Is,
Do you know how you said 2 times
yeah,
in the 30-day period? We have something that happens every month.
yeah.
So certain months, 30 days is not going to be long enough by day. So like 31 days.
Yeah. Yeah, so just to repeat the question was the 2x the peak, right? Is that configurable to 4x, I don't know, 5x the peak? Two things to that, right? One is it's not a static thing, right? It always is growing, is adaptable in nature. What I mean by that is, say, in the month of January, your peak was 30 megabytes per second, right? So that was your last known peak. So you would be having at least 60 megabytes per second of capacity. Now, say you, in the month of March, suddenly you saw a peak of, say, 70 megabytes per second. And now we will adapt that to 140 megabytes per second, right? So you're constantly growing, and that 2x is basically a starting point, right? So it's always an anchor point in terms of how much of headroom you want. So we believe that for most use cases, that 2x headroom is significantly enough, and it allows you to continue to grow. One thing that we're looking for feedback, but one thing that we don't yet want to do is kind of put it on you, right? Like, hey, is it 3x, is it 4x? Because at the end of the day, that's when management comes in, right? Like, you have to handhold that, because you have to decide whether 3x is enough. Okay? You have to then go back to 2x, right? That is something that we don't want to do with the on-demand mode. We're trying to basically take that overhead on us. So we believe that 2x is a good starting point, but we're going to evolve. As we're going to learn from customer use cases, we're going to evolve the offering. Yes, please.
For the on-demand limits, is there any specific reason for those numbers? And why do we have, is it possible also later you increase those limits?
Yeah, so the question was really around the limits for on-demand, which is the 200 megabytes per second. So when we looked at most workloads, right, so as a multi-tenant operator, we have the ability to kind of glean and see what customers are doing. We believe those covers vast majority of use cases, right? Like use cases where like a 99.9% of use cases, right? So that's number one. Number two is that we optimize it for the speed, right? Because we want to scale faster. So as we do more on the core offering, our goal is to increase that limit for sure. Right? But today, though, it's capped at 200 megabytes per second. Yes. Not at this time. So sorry, let's just repeat the question. The question is, can I control the top level? So, yeah. 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 Yeah, no, that's a great question. So the question is like, hey, I have a faulty producer that's just ingesting a lot of data, and not by logic, but by accident, essentially. Now, because you can ingest, obviously you're going to increase and scale up, right? Now, yes, there's no capability like that, just to answer that question real quick. But I think what happens even in that scenario is that because you're not scaling up and paying for that fixed capacity, yes, you're paying for that interim period where you just had a spike in that producer was ingesting more data. So that throughput that spiked is what you're paying for. but it's not like you're paying for that capacity forever. So it may not be as punitive as you think it will be, just because you're not paying for that capacity. But so hopefully that will not be an issue. But again, you can use the provision mode if that is a key requirement for you to apply those throttles essentially at each application level. Question? I'll take the question. Come back. Sorry. Yeah. Good.
So you mentioned sharding. You can do on demand, right? Or I missed something.
Okay. So the question was, can you do resharding with on-demand? Was the question?
Yeah, I think you mentioned it.
Oh, sorry. So no, so the difference, the core difference between on-demand and provisioned is, there is. You don't do that. So we do that for your behalf, right? Yeah. Yes, please.
From the moment throttling occurs, how long does it take for the new shards to come online?
It can take up to 15 minutes. So it can happen sooner because in this example, as you can see, it happened like in 2 minutes. So it depends, but the most it can take is 15 minutes. And it's also progressively better, right? It's not like it'll take 15 minutes and then you see 0. It'll get progressively better and takes up to 15 minutes to get to 0. Yes, please.
So when if there's a heavy spike in the on-demand mode, can it still throttle that time?
If there, sorry, mind repeating the question.
So can it still throttle in this on-demand mode if there is a very heavy spike?
Yeah, no, there is certainly a possibility of throttling. There are two reasons where it might happen. The question, sorry to repeat the question, was like, hey, when do you see throttling in the on-demand mode, right? Is that a fair way to summarize that? So there are two reasons where you might see throttling in the on-demand mode. One is obviously if your traffic increases suddenly more than 2x your last peak. So your last peak was 30, so you're trying to ingest 70, you will be throttled because you can only do 60. But then you will scale up to quickly within 15 minutes, so your throttles eventually will come down. The other reason where you might see throttles in the on-demand mode is when you use an unbalanced partition key. So just to kind of level set, you use a partition key to write into a Kinesis data stream, right? So when, typically it's if you say you use a product ID, right? Product ID is your partition key, that's how you're writing data. And all you're doing is selling one product. So then what happens is all the records are always assigned to the same shard, right? So the shard definition, which is 1 megabytes per second, does not change. So we'll split that shard just to add more capacity. But after like 8 times we split a shard, it's done, right? So because you still have to use a balanced partition key when you're writing to Kinesis data streams, just like you do today. So that's the other scenario where you might see throttling. Yes, please. Lambda?
About lambdas.
Okay, yeah.
You have lambdas consuming Kinesis.
Yeah.
And currently they are structured by shards.
Okay.
So would they know automatically that new shard just came in?
Yeah. So the
Add additional
yeah.
parameter so it doesn't integrate with lambdas?
That's a great question. So the question, just to repeat, is if you're using Lambda and if you're scaling and you're adding more shards, can Lambda know that, hey, there are new shards that are being created? Right, so let me just talk a little bit about how resharding works in general, right? So when you reshard a stream, each shard, shards in a stream share a hash key space of 0 to the power 198, right? So if I have two shards, shard 1 could be 0 to the power 196, shard 2 could be 2 to the power 196 to 2 to the power 198, right? That's to share the hash keys range. When I split a shard, I'm splitting the hash key range. I'm saying, okay, I want to take this shard and I want to split it, the hash key range. So when I'm splitting a shard, I close an existing shard and I create new children shard, right? So a parent shard gets closed and children shards gets created. In Lambda, that discovery of new children shards is automatically done by that platform. So you have no reason to be concerned about or what have you when resharding happens. It happens today, right? Like when you reshard a stream, Lambda knows that there are new shards and it starts processing data from those new shards. And that will continue to work in the on-demand mode. And we've also made optimizations to the latest Kinesis client library. If you're not using Lambda, if you're building it on EC2, you would be using that library. We have built optimizations where that can happen very quickly. So as you're doing a lot of split and merges, you're creating a lot of intermediary shards, and KCL would know the lineage of those shards to say that, yeah, this parent has these 2 children shards, so once I complete reading from this parent shard, I'm going to go discover data from these children shards. So all of that optimizations are bundled into the latest KCL. which will obviously give you better performance. Did that answer your question? So there was a question. Oh. Yes, please.
Do you have any statistics on the cost difference between provision? I know you had the
Yeah.
data slide, but do you have
Yeah.
any like use cases of customers? What do you expect?
Yeah, no, I think that's a great question. So the difference is, the question was really around price difference between provision and on-demand, right? So like I said, I think it really varies because, like, I'm going to talk about some of the use cases, right? So if you have a workload that has a peak to mean beyond like 5 or 6, right? So where the peak is 6 times more than the average, typically you would over provision, right? So one thing that we've learned from this exercise is we are not great at estimating capacity, not just customers in general, right? So you're actually running at 8% utilization of your existing shards. So for those streams, when you move it to on-demand, it's actually economical to run it on on-demand. And the power of this is you can use both, right? So you can take your streams today and you can look at, hey, this is cheaper on provision, so I'll stay on provision. And these are cheaper on on-demand. So what you can do is you can move those set of workloads over to on-demand and thereby reduce your overall cost while still getting the benefit of using automated capacity management. So hopefully that answered your questions. Unfortunately, we don't have any exact answer for that. If you have small records, if you have more than 2 consumers, if you have high peak to mean workloads, then on-demand is a lot more cost-effective than provision. I have 8 more minutes. I'm happy to take more questions. Yeah. I'm sorry, I can't hear that well.
In case I want to preserve ordering for
Oh, yeah.
a certain set of records,
Yeah.
and you have certain capabilities that does it and assign them to the same shard,
Yeah.
how would you do it in this type of system? So there are libraries to support this type of behavior where you need to have not all the records, but set of the records where you need to support certain order.
Yeah. So just repeating the question, right? So really about ordering guarantees with Kinesis, right? So with Kinesis, one of the things that you get by default is stable read-side ordering, right? So if you write 2 records, they're always read exactly the same order in which they're stored, right? So that gives you, semantics like at least once processing. Those are retained in on-demand, right? Because what you're doing is, say you have 2 shards. So you're writing to 1 shard, and all those records are always routed to the same shard, regardless of which mode you're in, right? So the core role of a shard does not change between provision and on-demand mode. So thereby, guarantees like ordering do not change between the provision and the on-demand mode. But again, if you get more control in the provision mode because you know exactly which shards you're writing to.
Right, but the whole point is how you distribute it across the shard. Like this distribution algorithms are going to change, right?
Not necessarily, because what you do today is, like on the processing side, if you're using KCL, so what it does is it distributes the shards processing across a bunch of worker nodes, right? So you could have 2 workers. Worker 1 is saying, I'll do 2 shards, you do 2 shards. Now in on-demand mode, the only difference is you might have 6 shards, right? Because you're scaling up for a peak. So all you're doing is, yes, you have more shards to process data. So your worker 1 now will be processing 3 shards. Worker 2 will be processing 3 more shards. The nature of ordering does not change, right? Because you're still writing to that shards, and the processor that is reading exactly in the same order in which those are written into the shard. So the guarantees around ordering do not change just because you have an on-demand mode where we are managing shards for you. Oh, sorry.
When using just a KCL, normally if you want to have multiple consumers, having that shard splitting in order to parallelize the compute and processor, different partition keys and shards. We normally used to have instances that do not, in a number that are not greater than the shards number, to avoid multiple processing, right? What happens if we use the on-demand and it's going to scale up and having more shards? What happens other way around. So if we reduce the shards level, but still we have a number of consumers which are greater than the number of shards.
Yeah. Yeah, in this case, what happens, like just like today, is that there will be some consumers that will be idle, that won't be processing any shards, right? Because what the way it happens is, you could have as many record processors as many number of shards you have, right? Because there's a single record processor that's always tied to a single shard, right? So if say you have 10 shards and you have, I don't know, 20 instances, then those 10 instances are doing nothing because shard assignment works in a way that is distributed across, in some cases, even 5 instances, because it doesn't, if it says that I have enough capacity, it doesn't even steal the lease, right? The lease is still assigned to whatever instance you have. So that behavior does not change. Please, yeah.
So I think, according to what you say about data aggregation and data rounding, if I have a data aggregated stream with provision, I will wait until sending like those 25
Yeah.
KB, right? And
Yeah.
on demand it's going to be 1 KB.
Yeah.
So if I switch between them, probably the only effect I will see is like, okay, with the on-demand I'm sending data like almost real time because it's 1 KB and provision is going to wait until the 24 KBs are met. Is that correct? Or?
Yeah, just to clarify, right? So the question is asking, the question really around is, in provision, you have this 25 kilobyte rounding factor, and on demand, you have 1 kilobyte rounding factor, so how does the dynamics work, right? So just to kind of summarize that. Just to be very clear, right, Kinesis data stream doesn't aggregate or buffer any data, right, just to hit that 25 kilobyte limit. What customers typically do is, in their producing application, they basically buffer to say, yeah, let me wait till I get 25 records, just as an example, and then I can write a 25 kilobyte chunk into Kinesis data streams. That's what you do today. You're right in the sense that when you move to the on-demand mode, you can still do that. It would work, right? But over time, you would say, why do I need to do that? Right? Because I have a 1 KB rounding factor, so I don't have to build that complexity anymore. Because when you buffer things at the producer end, you could be building things like back pressure, right? You could hit a TTL limit, right? So those are some of the complexities that you have to deal with if you're trying to do buffering in the producer side. So if you're having a lower record, like a record rounding factor, that variable goes away. Now you might still do it because you want to drive more throughput, right? Because now you can drive more throughput by batching a bunch of requests to a Kinesis data streams write API, which is a put records API. You still would do that, but you're not doing it to save costs, right, or optimize costs. Yes, please.
Might not guarantee that the order of puts or the single puts are respected, of course. That is the KPI. If you buffer, then...
Yeah, that's always the case with KPL. KPL doesn't guarantee ordering because it focuses on like buffering, and that can flip bits, if you will, while it's doing that. So there's also a native process that it runs. So within that communication between the Java wrapper and the native processor, ordering is anyways not guaranteed, right? So yes, if you care about ordering, you have to be using the put record API, the singleton API, where you send a record, you get a response back, a sequence number, and you send that back to the next record.
With this on-demand scenario, we would pay less or more, since the rounding factor is 1K.
Yeah.
So we are not losing so much in sending a put record unless you have the right buffering strategy.
Yeah. Today you're absolutely paying more, and on-demand might be cheaper, which is one of the comments I made, right? Depending on the type of record sizes you have, it might be cheaper to use on-demand. Yeah.
So if I have a put record, so single put record, in order to guarantee the order, I would pay less using on-demand?
Yes. Again, like I said, it's not like a blank answer because depending on number of shards you have and things of that nature. But yes, directionally, yes. Awesome. Thank you so much for coming to this session. Appreciate your time. And I can stay back, take more questions if you have them. Thanks once again.